Alright, so this is 6.4 from Math 20-1. Trigonometry, it's called the Sine Law. So this takes a little bit of a turn in what we used to be doing for trigonometry. We're going back to some basic triangles and solving them like we used to in Math 10C. The difference is, in Math 10C, every triangle we ever had was a right triangle. In Math 20-1, our triangles are no longer forced to be right-angled triangles. So that means there's acute triangles where all the angles are less than 90, and we also have some oblique triangles where at least one angle in the triangle is greater than 90. But all that really matters here is that we no longer are going to have 90-degree triangles all the time. So if we want to be able to work with and solve triangles that aren't 90-degree triangles, we need a new method. And that first method we're going to learn is called the Sine Law. And the Sine Law states that the ratios of sine an angle A divided by the side length of angle A equals sine of an angle B divided by its matching side length B. Alternatively, we could also say that it's equal to the third angle and third side of any triangle. Whenever we're using the sine law, we really only focus on like one part of it. But it is important to note that you could technically also focus on this part of it. I mean, it's all the same. All it's saying is that if you take sine of an angle and divide it by its side length, it's equal to the sine of another angle divided by its side length. This beautiful equation we have here, that's the formula we use when we're looking for angles. So we use this one anytime we are looking for a missing angle. They've created another sine law that looks almost the same, and it's used for side lengths, and it's A divided by sine A equals B divided by sine B equals C divided by sine C. These are the exact same law, it's just one's flipped upside down, and that makes it easier for us to find missing sides. When you're given these formulas on a test, it won't say which one's for sides, which one's for angles. You just need to know, if you're looking for an angle, you want to pick the one that has the angles on the top. If you're looking for a side, you want to pick the one that has the sides on the top. Alright, let's see how this works. So the sine law can be used to determine missing sides. And we're going to do an example of finding missing sides right here. So it says an example, triangle GHJ, determine the length of G to H. So G to H is from here to here. So that's the side length that we're looking for, little j. To do that, we realize that we don't have a 90-degree triangle here. We have what looks to be an acute triangle. It's definitely not a 90-degree triangle, which means we can't use SOHCAHTOA, we can't use Pythagorean theorem, we have to use the sine law. And you know you're using the sine law because we have something called a matching pair. So I refer to a matching pair whenever I have an angle and a side that's across from the angle. So in my case, that right there, I highlighted in blue, that's my matching pair. Whenever I have a matching pair like that, that signals to me, oh, I need to use sine law. We then realize that we have half of a matching pair right here. Half of a matching pair tells us that we need to set that thing up so we can find something. Using sine law, it said that if you go sine of an angle, in this case I'm going to say angle G, and I divide it by side G, so this would be side G over here, it would be equal to sine J divided by side length J. Now that's the formula we would use if we were looking for an angle, but we're not looking for an angle. In this case, we're looking for a side length. So we actually want to flip these things, and instead we want to use G divided by sine G equals J divided by sine J. We want to use this one because since we're looking for a side length, we want a side length on the top. This is nice and easy. Now that we've figured out which formula we want to use, we just need to plug in our information. So G is equal to 7.8 divided by sine G, so divide by sine of 51, equals J divided by sine of J. And sine of J is 44. To solve this thing, we want J all by itself. So we've multiplied both sides by sine of 44. And if you just punch that in your calculator, so in your calculator you're going to go sine of 44 times 7.8 divided by sine of 51. Make sure you use brackets to close everything off. You should get that 6.97 equals side length J. And it says nearest tenth of a centimeter, so this rounds to be 7.0 equals J. Quite easy sine law is. It'll take a little bit of practice, but once you get a hang of it, it's really easy. So that's one example of sine law. A second example of sine law is that it can be used to determine missing angles. So below we have another problem. In this case, it's telling you to find angle N. So it's saying, what's this angle right here? And right away you notice we don't have a 90-degree triangle. We have an oblique triangle here. And we have a matching pair, right? An angle and a side right across from it are both given. We call that a matching pair. Now, unfortunately, the other piece of information we have matches up with angle P. It doesn't match up with angle N, the one we're looking for. So we're going to have to find angle P first, and then we're going to have to see if we can't figure out a way to find angle N. So because this is the half information we have circled in green, we have to work with that. We don't really have a choice. We're going to set up our formula. Our formula was sine of an angle, so we're going to say sine of M over little m, where this thing is little m, is equal to sine of P divided by little p. This guy down here, the 10, is little p. You plug that information in, that means the sine of 92 divided by 11.8 equals sine of P divided by little p, which is 10. Just like before, we use this thing by itself, so we multiply by the bottom. So both sides are times by 10. You punch that thing in your calculator, you go 10 times the sine of 92 divided by 11.8, and you get 0.8469, blah, 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 equals sine of P. Remember, if you want to figure out what P is, you need to then go second sine, and this little guy here with the -1 will show up. And then in the brackets, you put that answer you got before, so the 0.8469. That thing goes in the brackets, and that'll tell you what P is. In our case, P equals 58 degrees. Now that's wonderful. We figured out that P equals 58 degrees, but what we didn't figure out what N was. So if this thing's 58, we still need to figure out what N is. remember the trick that all triangles, if you add up their angles, you get 180. So if you're looking for this third side over here, all you have to do is go 180 minus 92 minus 58, and you'll find that 30 degrees is angle N. So we'll circle that right there. Okay, these are a couple really basic questions. We'll get into a couple more here. We have 3 examples. This one says, determine the length of Q to R. So from Q to R. You're trying to find that blue side that I just highlighted. The first thing you notice is this is not a 90-degree triangle. Since it's not a 90-degree triangle, we can't use Pythagorean theorem and we can't use SOHCAHTOA. So instead, we have to figure out a different way to solve this thing. We have a third problem here, or a second problem, and that problem is we don't have any matching pairs. Remember, we were looking for a matching pair where the side and the angle match each other up. But in this case, all of our angles that we're given don't have sides that match with them. And the only side we do have is matched up with an angle that we don't have. So what we have to do is remember our trick that all angles in the triangle add up to be 180. And if we do that, we can figure out that angle Q is equal to 180 minus 75 minus 39, and that'll tell you what your one angle is. So 180 minus 75 minus 39. That means our angle in here is 66, and now we do have a matching pair. So we want to work with this right here. And since we're looking for this guy over here, that's our other pair that we're going to have to work with. Our formula says that if you do a side length, like side Q, this is side Q over here since it's across from the big Q, divided by sine big Q equals the other side divided by the side of that side. And we're using this one because we're looking for a side length. Now we just have to fill in the information. So 8.1 divided by sine of 66 equals little p, which we don't know, divided by sine of p, which is sine of 75. If we want to get the p all by itself, what we're going to have to do is multiply both sides by sine of 75. So they cancel out. What you do to one side, you have to do to the other. You punch that thing in your calculator, and that'll give you your answer. So we go sine 75 times 8.1 divided by sine 66, and you get p is equal to 8 point, it says nearest tenth, so 8.6 equals little p. So easy peasy. I have one more example here where we have another basic triangle drawn for us. Now they're asking us to look for angle G. Angle G is right here. Again, we look at our triangle, we notice it's not 90 degrees. Since it's not 90 degrees, we know that we have to use Sine Law. We can't use SOHCAHTOA. We can't use Pythagorean theorem. We also notice that we have a matching pair. Those matching pairs tell you what you're going to work with. So I've got a matching pair here. And I also have a half pair. So half of my pair is here. And unfortunately, it doesn't match up with the angle we're actually looking for. But that's okay, because that means there must be some way that I can connect these things. So even though I don't want to find this angle J, I'm going to go find it because it might help me find angle G. My formula here is going to be sine on the top because I'm looking for an angle. So sine of h over little h is whatever is right across from sine of big H, equals sine of j, which we're not sure what that is yet, divided by little j. Little j is whatever is directly across from big J, so 6.1. We're just writing little j. That's my formula. If I fill in my formula, I have sine of 65 divided by little h is 8.6 equals sine of j, which we don't know what that is, divided by little j, which we know is 6.1. We want to get sine of j all by itself. We need to multiply both sides by 6.1. So we multiply both sides by 6.1. And you're going to put that thing in your calculator. So 6.1 times sine of 65 divided by 8.6. And you get 0.6428. And it keeps going forever, equals sine of j. Remember, anytime you're looking for an angle in trigonometry, you're going to have to hit second sine or second cos at some point. So this one's going to be sine, so second sine right there, and then in the brackets of your calculator, that's where you put that number, and you put the full number in there. Don't just put in the first couple digits. You do that, and that'll tell you what j is. In our case, j is 40. Now that's great and all, but the question wasn't asking you for angle j, it was asking you for angle g. So we're going to fill this in. We know it's 40. We remember our trick, and our trick was if you know two of the angles, you know the third one, because they all have to equal up to 180. So angle G is going to equal 180 minus the other two. So minus the 40 minus the 65. That will tell you what your angle G is. You go 180 minus those numbers. And you should get 75 degrees. Just like that. Alright, our last question. This one's a little trickier because you notice that they didn't draw it for you. So you're going to have to remember how to draw triangles. Now, I'm not a very good artist. So when I draw these triangles, my triangles pretty much always look the same. I don't try to draw them to scale. I'm not worried about that. I'm just going to draw a triangle, and then I'm going to label it properly. It's okay if the triangle is not exactly to scale. You don't need it to be exactly to scale. So in this case, it says in triangle DEF. Well, I'm going to draw a triangle DEF. I have no idea if that's what it looks like. I have no idea if that's to scale, and I really don't care because I'm going to label it properly, and that's what matters. It says from D to E is 5 centimeters. So 5 centimeters. It then says angle D is 28, so in here is 28. Now that definitely doesn't look like it's 28 degrees. That's not very to scale, but it doesn't matter if it's to scale. It matters if it's labeled properly. It then says F to E is 8, so this thing's 8. There, we've drawn our triangle. It might not be perfect, but we've drawn it, and it's going to work for us. Question B says solve the triangle. Anytime you see the words solve the triangle, that means you have to find all missing sides and angles. So what we need to do is find everything we possibly can. To start off, we're going to recognize we have a matching pair. And anytime we have a matching pair, that means we're definitely going to use sine law. The next thing we notice is we have half of a missing pair. That half a missing pair is what we're going to have to work with, and we're going to have to find the other missing half to that pair. In this case, the first thing we're going to have to find is this angle in here. So we set ourselves up. you set up, since we're looking for an angle, you put the sines on the top. So sine of d over little d, so that would be this guy over here, is equal to sine of f divided by little f. Little f is directly across from big F. We fill in our numbers, so sine of 28 divided by 8 equals sine of f divided by little f, which is 5. We know that if we want to get sine of f by itself, we're going to have to multiply both sides by 5. We punch those numbers in our calculator, so we go 5 times sine of 28 divided by 8, and we get 0.2934, but we know we have to go second sine of that number. So 0.2934, blah, blah, blah. You punch that in your calculator, that will tell you what angle F actually is. And in our case, it is 17 degrees. So angle F is 17 degrees. That's the first thing we're going to box. It's the first good piece of information we have. This thing right here, 17 degrees. Now, we're going to use our little trick. Our little trick tells us that if we know 2 of the angles, we can definitely find the third angle. And to find the third angle, what you're going to do is you're going to go 180 minus the other 2. So 180 minus 28 minus 17. You put that in your calculator, and you'll find the missing angle that we're looking for. And in our case, it's 135 degrees. And this is definitely not to scale. But that's okay. It doesn't need to be to scale. So, we have angle E equals 135 degrees. That's another thing we're going to want to box. Now, lastly, we're missing side little e over here. And what we notice is we now have matching pairs, and we have a new half a missing pair. So we can do sine law again, but now just using the new half missing pair. A good question here might be, should I use my pair of the 28 degrees and the 8, or should I use my pair of the 17 degrees and the 5? And it doesn't matter which one you pick. I'm going to pick the 28 and the 8 because those were given to me. And if I use information that was given to me, I'm less likely to make a mistake than if I use information I tried to find myself, just in case I made a mistake in that first problem. So what I'm going to do is I'm going to set up my new little thing here. Remember that side D. And I'm going to put the sides on the top this time, so 8 divided by sine of 28 equals E divided by sine of 135. And I want to get that E all by itself, so I multiply both sides by sine of 135. Cancels, sine 135. If I punch that entire thing in my calculator, I go sine 135 times 8. My calculator has stopped working. Times 8, there we go, got it to work. Divided by sine 28. And I find that little e is equal to 12 point, and it says side length to the nearest tenth of a centimeter, so 12.0 equals e. Now I've completed the triangle because I know all my missing sides and I know all my missing angles. That's called solving the entire triangle. Alright, that's it for sine law. Remember, you're going to have your entire block tomorrow, or later today, depending when you watch this, to work on practicing your sine law and practicing your other trick. So bring questions, watch this again if you need to, Try to come prepared, ready to ask questions and learn. See you soon.